The Mars rover Opportunity a few years ago was exploring around the rim of a crater called Victoria. During a certain multi-day period, it traveled 176 meters at 340 degrees azimuth before turning to azimuth 104 degrees and going another 154 meters. We're going to draw a vector diagram, including the resultant, and figure out how far was Opportunity from the starting point and in what direction was it. Now I've gone ahead and I've written down the two legs of the trip. This picture over here is showing the full multi-day traverse. We're only doing two of these legs. The first thing I need to do is to set a scale, and the scale that I'm choosing is to use 1 centimeter on the paper represents 20 meters in real life. So let's go ahead and start. 176 meters with 20 meters represented by 1 centimeter on the paper means I'm going to draw this first one 8.8 centimeters long. The 154 meter leg, 1 centimeter equals 20 meters in real life, gives us 7.7 centimeters. So those are the lengths of the two vectors I'm going to draw. Now this first vector is almost straight north. 104 degrees azimuth is 14 degrees south of the east. So I'm going to start near the bottom of the paper. And I'm going to draw a line that is 8.8 centimeters long at 347 degrees azimuth. So here I'm starting a line at 347 degrees azimuth. Now what you can't see is that I am holding a real-life ruler over the screen to get 8.8 centimeters, and that takes us to right about there, 347 degrees. Okay, so that is our first vector. Our second vector, I need to move the protractor now. Its center is at the tip of the first vector I drew. Now, starting at that point, I can draw the second vector. Here I go, starting right at the tip of that first vector, drawing my second, adjusting to an azimuth of 104 degrees, a length of 7.7 centimeters. I'm laying down the real-life ruler here. Okay, so now I can draw my resultant. I've actually pre-drawn a little arrow here with a red color so it stands out. And I'm just going to move the two endpoints. So the tail of the resultant vector is at the starting point right here. The head of the resultant is at the head of the last vector I drew of the two. Now let me put some labels on here and measure its length and its direction. Moving the protractor into place, I see that the resultant vector is at an azimuth of 40 degrees, and laying down the ruler, see that this vector is about 8.4 centimeters long. So the resultant, its azimuth or direction is 40 degrees, and its magnitude is 8.4 centimeters. Each centimeter represents 20 meters in the real world. 168 meters from the start point at an azimuth of 40 degrees. Now if you take a quick look at the shape of our diagram, the black vectors representing the actual motion of the rover, up and to the left, almost north, and then down and to the right, almost east. If we scroll up to the image provided by the Mars Exploration Rover team, you can see that what we're talking about are these two traverses right here, part of the larger exploration along the rim of this large crater.